Welcome to Walkabout the Galaxy, the unstoppable astronomy podcast, where the science is universal, the opinions are personal, and the hosts are friendly.
Sometimes.
Sometimes. It's true. You've been kind of cheeky to me on more than one occasion.
Yes, it's just
Pot, kettle, black.
Oh. Wow.
Wow, this just got unfriendly.
The hosts are snarky.
That's true.
We are Strange Charm and Up the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram, but not including Snapchat, Pinterest, or LinkedIn, or several others
Okay.
that
sure.
I have not mentioned.
I
We're
don't know
not
if you
on.
can subscribe on those anyway.
We're not on Tinder or Grindr.
Grinder? Grinder?
But we are at walkaboutthegalaxy.com, where you can see how to order Walkabout shirt and support STEM education at the same time. You can contact us anytime at wtg@ucf.edu. Do contact us that way if you order a shirt so we can get it to you as soon as possible. Our Stumpers today are science fictional and motivated. Hannah's favorite.
Rolling my eyes already. Carry on. Yep.
Motivated a little bit by a bunch of articles I've been reading about the metaverse recently. So the metaverse, actually, originally that term was coined by Neil Stevenson novel from the 90s, I think. But the sort of completely immersed in virtual reality, and it's a standard thing that pops up in science fiction.
Yep.
And of course, Facebook has renamed itself Meta.
Yeah.
And they're kind of apparently going all in on Meta. Some of these articles reading like spending beaucoup money on their metaverse investment. And they just announced their latest iteration of their virtual reality headset.
Oh, good.
The sort
just
of,
in time for Christmas?
Yeah, this one though is really aimed at the professionals. It's not aimed at gamers.
I've seen a lot of commercials for these things lately.
I don't know anyone who cares
aimed
about it.
at this, and it's all like, in the future, your classroom will be blah blah
Right.
blah, and you're like, no, it won't.
Yeah. I don't know.
Anyway, I
don't know.
think it's.
We're definitely not there yet. Like, I have a VR headset for gaming,
Sure.
and it's fun.
Sure.
But I don't spend a lot of time on it, and after an hour, it's really uncomfortable. I want to get the damn thing off my head.
Yeah.
Anyway, that's what prompted this Stumper.
Okay.
And there is an inherent contradiction or problem in this Stumper, as you will see in a second. Because the Stumper is, if you can choose one of these two thingies from the science fiction realm, which would you choose? And these are, I'm going to use Star Trek terminology here, Hannah, but part of that whole explanation was to help you understand
Okay, thanks.
the Star Trek
Yep.
terminology. The choices are the holodeck
Okay.
or transporters.
Okay.
So for holodeck, think amazing VR.
Yeah.
Okay.
You
Virtual
walk into a
reality
room,
space.
and
Yeah.
the room can become whatever room you could imagine,
Without boundaries.
from reality or
Okay.
anything else.
Yeah.
Right. And transporters, you know what the transporters are. You step in a thing, you get
It zapped you somewhere
zapped
else.
to someplace else.
Yeah.
And the reason it's a little bit of there's an inherent contradiction is that the holodeck uses transporter technology.
Oh.
So we would really get both.
Oh.
But for the rules of the Stumper, you can only have one or the other. Which do you want? Do you want to be able to like go into a room
Transporter.
Yeah.
and have it be just as if you were
Transporter.
on the moon, or do you want to beam to the moon?
Transporter. Yeah.
Really?
I think so.
Okay.
Yeah. I think I like traveling,
Yeah.
and I get how you could do the holodeck and like pretend to go somewhere,
Right.
And you could climb Mount Everest, but not actually climb Mount Everest and
Right.
never be in danger.
Right.
But
It
like
feels
in,
more
like
practical.
like in Deep Space Nine, right? They go and they like have dinner at his dad's restaurant.
Right. Go to Quark's bar. You actually hang out with people at the bar.
Yeah.
Yeah. So you want to keep rooted in the physical universe
Plus-
or whatever.
Plus, you don't know
Meat
what's going to
space,
go wrong
I
in
think,
the
is-
holodeck.
That's true. The holodeck is the single biggest hazard to the future of the galaxy in Star Trek: The
Yeah,
Next Generation.
exactly. There's always holodeck malfunctions,
And it's about to take over.
and it takes over the ship, or like some evil entity gets into the AI of the rest of the ship.
Yeah,
and
you're really not selling it to me. I'm all about the transporter then.
Yeah.
Okay.
Yeah.
So you want to stay
We're both transporter.
in meat space,
In reality.
in reality,
Please.
and
Mhm.
not virtual reality. Okay. Well,
Are
It
you
sounds
a
like you.
holodeck?
Yeah.
Mark Zuckerberg, you heard it here.
Yeah.
Two out of three, at least, astroporks say
Transport us. Don't fake.
put
Brain
those
us.
billions into disintegrating people.
Yeah. Disintegrate and clone me.
and reconstituting
Willy
their
Wonka
atoms
did it,
someplace
so
else.
it's
Yeah.
weird.
Okay. Good.
Is that the new Willy Wonka?
Hmm?
The new Willy Wonka?
It's in
Oh
both.
no, he does it in the little TV thing.
Yeah.
Yeah, that's right.
What does he do?
He disintegrates people and reforms them.
Oh, jeepers.
Goes
Today-
well most of the time.
Today we'll talk about life on Mars and apparently a gigantic gamma ray.
Boat.
It's huge.
We
It's
may
the
t-
biggest gamma ray.
We may talk about creating cats inside black holes just because I think it's awesome,
Yep.
but I don't understand it, so we probably won't. But first, this episode of Walkabout the Galaxy is brought to you by the Instability Strip.
Oop, careful.
Tired of that same old routine day in and day out? If you're ready to shake things up in your life, come on down to the Instability Strip. You may see movie stars on the Hollywood Strip, but you'll see the real deal on the Instability Strip, as aging main sequence stars take a hop, skip, and a jump down our strip on their way to the Red Giant branch. And you may even see a red giant drop its shell for a brief jump
my.
back to the main sequence. So strip off your old habits and visit the Instability Strip, where stars come and go but never stay. The Instability Strip. What happens here only happens here.
Is that just a riff on Las Vegas?
Is that like, yeah, is it a holiday destination? Or a
Yeah.
vacation destination?
It is a vacation destination.
Is that the actual phrase?
What happens here only happens here
here?
is
It's gotta
the
be
actual
Vegas.
phrase.
Oh. Well, there's what happens in stays in,
Mm.
Yeah.
but it's slightly different than what
Fight
you're
Club?
saying.
So it is Vegas because
Okay.
they
They
want to
redid it?
they wanted to change their image a little bit
Ah.
away from the Sin City.
I see.
What happens in Vegas stays in Vegas to
What happens here
only
happens here.
which
I
is
see.
which is less
It is.
sinister sounding. Somehow. Yeah. Let's see. In our house of astronomical news,
Mm-hmm.
we take a walk down the JWST corridor, where the latest official JWST picture is one that we actually talked about a couple of episodes ago at Dragon Con, but has been officially released, which is these concentric but
Yeah.
non-centric consquaretric. What's
Ooh, interesting.
because they're
The
concentric
central
except
is
they're
the
not
same. The
circles.
center is the same.
That's
What part of
true.
concentric makes it a circle?
You're right.
Thank you.
So what is the
I
image?
stand corrected.
It's a square rings all radiating outward from a center.
Oh, cool.
It's like, looks
I've never
like
seen that.
perfectly spaced ripples. Interesting. You must not have been paying attention at that podcast we gave together at Dragon Con.
Or
Where-
I've
where-
forgotten a lot. I
There's
have
a
a
lot of
short-term
things that have
memory.
happened since then.
Yeah.
In any event, it's perfectly spaced concentric,
It's a Wolf-Rayet star that pulsates outward. And, has these
and the
concentric-
pulsations from the star would be circular, but
Yes.
these have corners in them.
Why do they have corners in them?
Something else is going on out there.
Yeah. It has to do with
Is that your
It has to
scientific
do with-
deduction?
so it's tree
How's that
rings.
for a great
They're like tree
explanation?
rings around this Wolf-Rayet star that are radiating outwards, but the actual shape of it has to do with the fact that it's in a binary pair. So it structures it not as it doesn't radiate isotropically outwards. It
Right.
gets this structure.
Yes, they've
Confined
got
structure.
17 shells showing more than 130 years of dust formation, and if this star, this Wolf-Rayet star, which is one of these highly unstable stars, was by itself with no neighbors or anything going on, then
And we
these
were
would be
viewing it
circular.
at the right. Oh yeah, at almost any angle because it's
Doesn't
pretty
matter.
much
Yeah,
isotropical.
they're shells,
Yeah,
so
it's
you should just see you would see these circles. But here we see funny corners, and funny corners are funny in astronomy.
Yeah, you don't expect
You don't
to
see many angles.
You don't see angles.
like
it's
that.
all curves and
Yeah.
things in
Pretty cool.
astronomy. So that takes us down to the
Artemis
Artemis
Corner?
Alley.
Artemis Alley?
Artemis Corner.
Artemis Corner.
Is it Artemis
It
Corner?
is Artemis Corner.
Yeah,
Artemis Corner.
Where
New launch date.
the rocket is still in the VAB,
Mm-hmm.
but it's going to roll out soon, I guess.
Yeah, so they're aiming for a launch on the 14th of November, just after midnight.
Which that'll light up the sky.
Yeah. So that's exciting, and they've got a few launch dates. I think there's like 3 that they've
So
listed. Hopefully,
And all 3 will be late night launches.
Yeah.
also,
Yeah,
Because
yeah.
they're in
that's a
relatively
Monday
close
night.
to each
Maybe I'll
other.
go out to it.
Yeah, I'm definitely going.
Yeah.
It's gonna be
Okay.
good.
I think I'll
So
go.
that's exciting.
Adjacent to the Artemis Corner,
Mm-hmm.
at least out at the pads at KSC.
Is the dartboard.
No, there's potentially going to be another Falcon Heavy launch.
Oh, that's right.
It's
we haven't
been
had one of those in 3
many
years.
moons.
Yeah.
3 years since the last Falcon Heavy launch. I actually was at Kennedy for that one.
So what's
Nice.
launching?
Some sort of Air Force, Space
Okay.
Force thing.
Yeah, super
Um,
secret. Probably.
Yeah, I think. Well, at least the first 2 were contracted to the Space Force, and then I don't know what the rest of them are going to be. But it's potentially launching October 28th
Ooh, that's
from
soon.
Kennedy.
Nice.
Yeah.
What time of day will that launch be? And are the side boosters returning to Kennedy?
The side boosters are returning. The main one is going to be
No.
lost. So they
Okay.
tried to catch it last time and it didn't work, and they just said they're not going to
Not
try to
gonna
catch it
bother.
this time. But the
Interesting.
side berth boosters are going to get retrieved.
Is there something about
Yes.
the Heavy that makes it harder to catch that central one on the
Yes. It goes.
boat? It's just a little bit less predictable
Yeah,
where it's going to end up when
I
it's
think
finished
so.
its burn.
Yeah.
Interesting.
And it has something to do with the amount of fuel and the trajectory. And
And if you saw that last Falcon Heavy launch, you saw the 2 side boosters come back and land like in formation.
yeah,
cool.
Side
it was.
by
We
side.
could see them coming in. We didn't actually. There were trees, so we couldn't see the final
Actual touchdown.
But I watched it a million times on video.
Yeah. So there you go.
But it was loud.
Yeah.
It was exciting.
That's cool.
Yeah.
Cool. And there is then, if you want to take a break, you can head over to the dartboard.
Yeah.
Mhm. Yeah, exciting news from D.A.R.T. So this was the
Double asteroid redirect test.
yes strike. The spacecraft went into the moon of Didymos. And they finally processed the data and found that it was a remarkable success.
Yeah,
Well-
we've been
well-
getting a lot of cool images of like the tail that's formed due to all of the ejecta.
Right.
And they were expecting to change the orbit by maybe like 10 minutes.
Yeah,
And
The-
I will say,
the orbital period of the asteroid moon around the
Yes,
main
sorry.
central asteroid, right?
yes, by about 10 minutes. And I will say, we were a little skeptical. We were like, I don't know. They're going to be able to do it. And then when it was all rubble piley, we were like, ooh,
Yeah,
did it change
it's
it
going
that
to be
much?
super fluffy.
But all this material got thrown off. It definitely changed the angular
Right.
momentum. 32 minutes.
A 32-minute change in the orbital period.
Yeah.
Mhm.
Interesting.
And I think they said minimum they're expecting like a couple of minutes, and they were hoping maybe 10.
They were-
So
yeah, they were
30
shooting
was
for
like
10-ish.
So where
Pretty
did they
high.
make a mistake? Presumably in the mass of the moon.
It's not
Yeah.
a mistake. I think it's still within the region of expected of the possible.
Well, you just said 2 to maybe 10.
No, I said it minimum 2. I think they were
They were
hoping
hoping
as
for
like an
10.
average-ish
Okay.
expecting 10. I think 30 was like that one of the higher limit.
Okay.
The minimum successful for the mission definition, the minimum successful change would have been 73 seconds or more.
Uh-huh.
So they did better than that.
I'm purely speculating
Yeah,
that
sure.
the reason that it was a much larger than 10 minutes, like, is that that moon is maybe, much more porous.
Yeah, I
and
mean,
less
I don't think we
massive
had
than
a
what they thought?
great. I don't know how accurate the mass estimate was.
Right.
And obviously, the fact that it was rubble piley, and the fact that we all of that material really got blown out. I think
Yeah.
a lot more than we expected.
Yeah.
So all of that
Stuff
mass
bounced
loss
off.
and recoil and
That
everything.
can give you up to a factor of 2. And then if it's more porous so that the mass of the thing you're pushing around is less than what you thought it was, maybe.
Yeah.
They would know with a binary asteroid system like that, you know the combined mass, and then presumably Didymos is much more massive than Dimorphos.
It is much more.
So they know that mass, the central
Pretty-
object, by seeing how long it takes that one to go around, but it's harder to estimate
Figure
what
out
the mass of the other one is. So
Mhm.
interesting. Good
Yeah.
for D.A.R.T.
I know. Good job, D.A.R.T.
Yeah.
Way to really smack that asteroid moon.
Right. Yeah. I'm going to just drop your trivia on you now.
Okay.
Be careful.
So you've got it. It's pretty basic trivia.
Okay.
Oh, no.
Astronomical, historical.
We are in pumpkin spice latte season, so it's good to be basic.
It's astronomical, historical trivia
Mm-hmm.
with, if you hold on to your horses,
This is not a pumpkin spice latte.
multiple parts.
What? Multiple parts
Hell
in a trivia
surprise.
question, so not that basic.
We love to talk about supernova
Sure we do.
and how cool it would be to see one in our own galaxy with the naked eye.
True.
Mhm.
When was the last time somebody did that?
Ooh. I should know this.
When was the last naked eye supernova in the Milky Way? Who is it named after? How far away was it?
Nighttime or daytime?
Yes.
It doesn't really matter.
Okay.
Yeah.
So I'm not I mean, just to be clear
Mm-hmm.
and to rule this out as an answer, in 1987 there was a supernova in the Large Magellanic Cloud, which is a satellite galaxy of the Milky Way. I'm not counting that.
Okay.
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 Isn't that one just called 1987?
SN 1987A.
Yeah, that's what
Yeah.
I thought.
Yeah,
It's
they
like,
all
that's
have
not
those
named after
exciting
anybody.
numbers. No, that's correct.
So.
Right. Yeah, that would also good.
Help me rule
puzzling.
that one out.
Good puzzle
yeah.
strategizing.
But does that mean it's more recent than that? No, that
It-
one wasn't in our galaxy, so it doesn't count.
It doesn't count anyway.
Okay, great.
Because it
Okay.
wasn't in our galaxy. All right, so we'll come back to that with some additional follow-on questions when we get to it. But let us start in our solar system.
Oh, I was gonna. Okay, that makes sense.
Yeah.
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 Solar system?
Yeah.
Yep.
Life on Mars? Or
It's a good
not?
song.
Because, okay,
Not.
Oh.
so...
Yeah, we're in the not camp.
Yeah, I'm in the not camp too.
Are you really? I would have thought you might have been more of a life on
Life
Mars.
on Mars.
Life on Mars.
No, I
Mars
think
might have life.
I think it's because every time an article comes out looking at habitability, news outlets kind of see that and think little green men, life is on Mars, and it just
Yeah.
drives me insane.
Right.
Sure,
So it's just
sure.
pushing me in this other direction. It's kind of why I wanted to talk about it, because
Right.
this article itself has been picked up and the title in all the news is
Oh.
Life on Mars.
Oh, right.
Okay, so
What's the actual title of the paper?
early Mars habitability and global cooling by hydrogen-based methanogens.
Awesome.
Yeah, awesome.
Or life on Mars.
Or life on Mars. It's basically the same thing. So there's been this study where they've looked at these little microorganisms of the same kind that we had in our early Earth,
Mm-hmm.
and they've modelled the conditions on early Mars to see if it would have been suitable for these types of microorganisms to grow and thrive. So these particular microorganisms, they consume hydrogen and produce methane. And there was
She means methane, just for our listeners.
for the UK listeners, methane.
Yeah.
And
It's probably more than the UK, right?
yeah,
Yeah.
and they basically showed that yes, these microorganisms could have grown and thrived
Mhm.
in sort of the upper layers of the Martian crust, but because it consumes so much hydrogen and outputs methane or methane, it actually changes the greenhouse effect of the atmosphere of Mars, and it would have actually caused a lot of cooling to the point
Uh-oh.
to the detriment of the microorganism.
Yeah.
So although these types of microorganisms could have thrived in the Earth environment because our atmosphere had a different composition, it wouldn't have had such a detrimental effect here on Earth, and life kind of could thrive. And this is showing that life could potentially thrive for a short period of time in different places, but it doesn't mean that they will all succeed. So it kind of plants this idea of there could be lots of life sprouting up in different places and then dying out pretty quickly, which is an interesting question in the search for life on other planets. And basically, yeah, there's the models were showing that it would have cooled the atmosphere, and that would have pushed any microorganisms to go deeper into the surface. And it kind of suggested some of the places where, if there was going to be these microorganisms, where could we find it? And it's basically the lower level, the lowest.
So these critters might have killed life on Mars in
Yeah.
essence by making it a hellish cold
Yeah.
wasteland. I'm curious about the whole climate change aspect of this. So the global cooling, so these things eat methane.
Eat hydrogen.
And hydrogen.
They eat hydrogen
Yeah.
and make methane.
Yes.
Yeah.
But methane is a greenhouse gas.
But not as much as hydrogen, apparently. Or something. I don't fully remember. Oh, here we go. They consumed hydrogen and CO2 as energy and carbon sources.
Okay, so CO2...
And methane as waste. And I think that switch...
Okay, so they take, basically, you get your carbon from the CO2, you get your hydrogen from H2, you make CH4, methane.
Which we often talk about, like cows making methane, and
that's a problem.
And it is a greenhouse gas. But the
That
cow...
It's not the only greenhouse gas.
But yeah, so CO2, so methane is a more effective greenhouse gas in terms of how much light it blocks, but it's much shorter lived. So I'm guessing that the cooling comes about because the CO2 can hang around for a long time in your atmosphere. It's much more stable. And the methane breaks down into hydrogen, and you lose that. So that would... You're trading a long-lived greenhouse gas for a short-lived greenhouse gas, and that is what ends up producing your cooling event.
I guess so. And then, so it's kind of the models are showing that what as a possible explanation for the cooling and the lack and the how the atmosphere on Mars was lost, because there are different suggestions of how that may have happened. But one of the things they've done is make recommendations of where they could have found, if this life did exist, where could it be found, and one of them is actually in Jezero Crater, which is where Perseverance is.
Convenient.
And they're collecting samples, hopefully, which will be returned one day.
Are those samples ancient enough to be going back to this time period? So this is...
I think they're from the right time period.
These are the Noachian period,
yes.
which is over 3 billion years ago, right? On Mars?
Yeah.
But it's easier to find 3 billion year old rocks on Mars than it is on the Earth.
True.
Because of no tectonics and no active volcanism at the moment, and much less weathering.
But yeah, so what this paper is kind of showing is it hasn't disproven life on Mars. It's giving suggestions of why the atmosphere may have changed and where to possibly find life if it has existed. But it isn't proclaiming that we have life on Mars. So I'm just kind of...
Right. It's not, but it's also sort of presenting an interesting idea that the current uninhabitable climate on Mars, or at least it maybe got to that uninhabitable state maybe sooner than it otherwise would have,
because of
as a result
life.
of some little critters
Yeah.
that had the wrong kind of chemistry. And we do have this kind of life on Earth.
Yeah, but they could thrive in our atmosphere, and it wasn't to their detriment, that change in the atmospheric composition.
And is that related to, that must be related to sort of other aspects of the terrestrial ecosystem, such as having liquid water oceans and a different carbon cycle, or I'm getting
Yeah, I mean, I think a lot of these organisms, right, on Earth, so that we think existed, were potentially in some of the more extreme environments on the Earth. So, like, if you look at where these, I like the name. I always love their hydrogenotrophic methanogenesis is the metabolic process
Jargon
for
much?
these things. Yeah.
So I like that this...
They're near other things like water and other energy sources and stuff like that, and so it doesn't modify and the atmospheric composition is different and thicker even then.
Yeah,
so
and we had more
much.
nitrogen, which was kind of like almost like a filler.
Mediates it.
Yeah. Whereas this, when it consumed all of that hydrogen and CO2, there wasn't a lot left in the atmosphere.
I like how this paper uses the word colonize.
Because it's actually...
As they colonize the Martian subsurface, methanogenic hydrogenotrophs drive atmospheric methane up and atmospheric H2 down.
Yes. Like little colonies of bacteria.
Those
little cities
colonizers, evil colonizers, ruined Mars for the rest of us.
They did.
Boy, War of the
That's why
Worlds.
you shouldn't colonize.
Yeah, they colonized their own planet though, but they were colonizing.
I mean, we colonized our own planet.
We did.
We don't know where they came from, though.
And we weren't
Ooh,
very
that's
nice
true.
about it either.
No.
Yeah. Okay, cool.
Pretty fun.
Yeah. Are you ready to jump out of the solar system?
Go
Do you
on
want
then.
to take a crack at the first trivia before we do so?
No.
Oh, come on.
Are you not ready?
Are we going to separate the trivia answers?
Yeah, we'll
okay.
separate them.
Sure,
Okay.
let's take a crack at it.
Yeah. So when was the last naked eye Milky Way supernova? Who was it named after? And what's the rest of the question? How far away was it?
1943. I don't think that's right. I have no idea is the short
Really?
answer. I feel like I will know it as soon as you say the answer, but I cannot
Okay.
think of it right now.
1850.
It's a good guess.
Okay. Actually, it is. Did I even write it down? I didn't write down the exact answer, but it's 16
Okay. Yeah.
something.
Hannah's
It was.
To the nearest.
you,
200.
Yeah. Named and who? So now that I've told you the approximate date, I'll look up the exact date here.
This wasn't the one in China, was it?
No.
Well, I mean, it was in
everyone would have
space.
seen it.
As in
Yes.
Thanks, Josh. Talk about snark. But yeah, everyone would have seen it. But by
Was
now,
that supernova in China?
well, but by now, so there are some from Chinese records.
Sorry,
right?
That's the one that I mean. The one that was recorded.
Yeah.
It might have been the earliest
There
one or
were-
something.
there
That's
were-
one of the earlier ones.
Yeah.
Yeah.
16. Anyway,
1601 would have been
sorry, I gotta
John
correct the date. Here.
Stevens.
John Stevens.
John Stevens. Come on. Yeah.
It's a scientist.
Galileo.
That's at least a better
It's closer. Yeah.
guess than
But
John
it's
Stevens, because John Stevens just some random name
Yeah.
made up.
Yeah.
Is it Galileo? I don't think it's not. There's not like
It's
It's
the
not
only. It's the only
Galileo.
one I can remember from.
1604. Sorry about the confusion
1604.
over the-
Oh, well, if it's 1604,
Right.
I still can't remember who it
Okay,
is.
Kepler.
Kepler
Supernova.
Kepler's. I don't think I knew that was called Kepler supernova.
It's now called SN 1604.
See, that's why.
Yeah. So after our next, we're going to jump out into the rest of the universe.
Okay.
And after we do that, your follow-up trivia questions will be, how many naked eye supernova have there been
In
recorded in
history.
historical records?
Here we
Okay.
go. Okay.
At least one.
At least one.
Yeah.
And there's another one.
From the one in China.
Yeah.
Yeah.
This one was also recorded in China.
Yes.
Right? By
But we talk
It was.
about it from the
it's
Western centric point of view.
we do,
Yeah.
but yeah.
Yeah,
Alrighty.
we'll go from dying stars
Yes.
to other dying stars.
Nice. Okay.
And talk about the formation of a black hole.
Love it.
Ooh. But we're not going to talk about black holes. We're going to talk about gamma rays.
The biggest ever.
The biggest ever gamma rays.
Gamma ray.
So there's this really cool observation recently on October. Some of the observations were actually on October 12th or something. But it's from October 9th. There was a gamma ray burst that was detected with a number of different telescopes. And because it was detected, it's been followed up with observations from a bunch of other telescopes too. And this is the largest gamma ray burst ever detected. So their energy is greater than 100 million electron volts. And some of the observations span tens of hours and days.
100 million electron volts.
Mhm.
So electron volts, so we have all these different units in physics that
Yeah.
just make everybody miserable who aren't
Yes.
physicists.
Yes.
Um,
Even physicists are miserable sometimes.
Sometimes. But I know my students are particularly miserable about
Sure.
physics units right now. So electron volts,
It doesn't really
are-
matter, I think.
well, the reason I was going to say it is because 100 million electron volts, the light that comes from
Sure.
hydrogen is in the sort of 10 electron volts.
Yeah.
So this is like 10 million times more energetic photon
Than
than the
just,
photon that you see in the
breaking apart a hydrogen gas.
that
in
which
your-
which is visible
Yeah.
sort of light energy.
Yeah.
I love that it's called the brightest of all time, or the boat.
In one of the articles, they call
Yeah.
it the boat, the
The
brightest of
boat.
all time.
Yeah.
Nice.
Yep.
Okay.
They could have called it like the gamma rayest of all time, and then it would be the GOAT.
Or just the gamma ray of all time.
Yeah. But so this is a really cool gamma ray burst that we think is much closer than a lot of the gamma ray bursts we've observed. So it's maybe only like 2-ish. I've seen some articles say 1.9 and some say 2.4 billion years ago, or light years away. So it happened 1.9 billion years ago. And it's in the direction of the constellation Sagittarius. Yeah, that's like relatively close for gamma ray bursts.
Yes.
And so remember, so gamma ray bursts, and probably this one, occur when you have a dying star. When a massive star is collapsing under its own weight, you have a black hole that can form. And as that black hole is forming, though, it has these powerful jets that sort of come out through the center, and they go out through the dying stages of the star, and it produces these X-rays and gamma rays as they go out into space. So there's some pretty cool artwork that's come along with this. And we've observed it in X-ray. We've observed it with a bunch of space-based telescopes, and then there's a bunch of ground-based Gemini telescopes that have been used to observe in other wavelengths as well.
Right. So that, those gamma rays, you don't see those with your generic optical telescope.
Nope. You gotta have a gamma ray telescope.
They'll go punching straight through your optics.
They will. Yeah.
I like as well because it's saying that it's an opportunity to better understand the origin of the heavier elements than iron, and seeing whether they all come from neutron star mergers or also from these collapsing stars that trigger these gamma ray bursts.
Yeah, because it's so close and because it's so bright, we have a lot more data and like better resolution to study. And it happened, and we were able to sort of swivel all these telescopes to look at it in lots and lots of different wavelengths. So we have a lot more data about it.
Can we get JWST to look at it?
No.
Not a good. Well,
No.
I don't know.
Some of the afterglow might be interesting, but
Yeah.
I think I don't know what wavelengths they have. They have also seen it in other wavelengths. They've also seen it in most of. So they've used some of the telescopes on Gemini to look at what's called the afterglow. So sort of like the light that's dying down after the initial explosion, and they are like Swift. And then we've talked about before on the podcast. We've talked about NICER, which is this
That's the one on the space
telescope that's
station,
on the space station, and it has a friend called Max-C. That's a Japanese detector that's also on the space station now. So those are both X-ray telescopes, and so those have both pivoted to look at this outburst, which is pretty. I don't know. It's pretty. I always love it when we get to see when we have these new observations, and now we have all these different telescopes that can look at it in lots of different wavelengths. And so I assume in a few months, in a year-ish, we'll have a follow-up paper where it says this is what we learned from this gamma ray burst.
But it's also important to note as well just how rare this is, because they say it might not happen, in our lifetimes.
Yeah.
Right.
Exactly.
Kind of like
Big
those
deal.
supernovas in the Milky Way.
Supernovas.
Yeah. Now, what was the energy of these things? Because I'm seeing something that's saying 18
TeV.
times 10 to the TeV.
Oh wow.
Is that what you?
I was looking at it, and I was looking at the thing I was looking at was maybe from a different telescope, so it might have been a different. What are you looking at? Tell us what you're seeing.
I'm seeing 18 times 10 to the 12.
Was the total energy of the
flash released carrying a record 18 tera electron volts of energy.
That's more.
Yeah.
So much energy. What about?
Really breaking records in the amount of photons and the energy of the photons that are reaching us.
Biggest gamma ray ever.
Mm-hmm.
Yeah. It is such a big gamma ray. It's got so many zeros on it.
It does.
Cool. Yeah, those things that exploding stars.
Yeah.
You mentioned making elements heavier than iron, which the ones lighter than iron we just crank away inside stars and they just sort of turn them out, kind of going about their daily
bog
business. Right. Box standard, right. And but to make the heavier ones requires these catastrophic cataclysms at the ends of stellar lifetimes.
So dramatic.
Yeah. So there was a LIGO, the Gravitational Wave Observatory, detected this neutron star merger event, which confirmed some theories about like the formation of gold, and one of many elements heavier than iron. That's where that stuff comes from. The gold in your jewelry is formed in those cataclysmic stellar explosions out there in the Milky Way from more than 4.5 billion years ago, because it ended up making it to our solar system. It's just cool.
Yeah, makes you appreciate your jewelry a lot more.
Right? Just like anything, all of the things that are us.
Yeah.
Right.
Yeah.
Yeah.
Yeah. One of the other cool things, and I think this is the tera, what was it? You said you saw the 18 tera electron volt?
Yes.
The photons were detected with a Earth-based telescope, but it ties into the fact that there was actually disturbances in the ionosphere detected.
The Earth's upper
Of
atmosphere.
the Earth's upper atmosphere detected due to this event that weren't, so they weren't radio transmissions from the gamma ray burst, but the incoming energy changed radio transmissions in the
Whoa.
ionosphere.
That's cool.
That's really
Yeah.
cool.
That's wild. So something 2 billion-ish light years away blows up, and the gamma rays, very high energy photons, make it to our upper atmosphere and perturb it enough that our
They were
use
from-
of the ionosphere for transmitting radio communications is
it ionized the atmosphere slightly differently, and it changed the
how
radio.
we- yeah.
Wow.
that's wild.
It's pretty cool.
Because we're like, we're part of the cosmic environment. We usually don't think of that extending out to galaxies and stars that are 2 billion light years away. Right?
No.
It's like those are these sort of abstract things that are fun to study. But okay, well, are you ready for?
Here we go. The highest photon energy detected by the Fermi Large Area Telescope reached 99.3 giga electron
Wow.
volts.
Okay,
So it's a
that's
lot
what you
bigger
said.
then.
100
Somewhere-
million electron
yeah.
volts. Yeah. Okay.
And then, but
the
there
number
were
I
photons.
was reading was the total energy.
But there were photons that were at that TeV energy detected with this other telescope. But I don't get why they. But it's not clear what how those photons A got here, and B, like what this telescope is detecting. I think.
Now I'm confused.
Yeah, it's a confusing statement. So let's
Okay.
move on from it.
Okay, so speaking of exploding stars, then
Yes.
closer to home in our
Closer to
Milky
home.
Way, the last time
Fewer than 8.
there has
2
been
light years.
a naked eye supernova in the Milky Way, 1604.
Okay.
Observed. It was visible in the daytime. You asked earlier if it was visible in the daytime. Yes, it was visible in the daytime for 2 or 3 weeks. Gradually faded over time. How many events like that are there in the historical record?
4.
7.
It goes to Addie with 8.
Ooh.
number.
Okay.
Interestingly and famously,
That's so few.
Tycho had observed one just 30 years prior, in
Oh,
1572.
What a
Tycho's
time to be
supernova.
alive.
I
Right?
know.
That was an exciting time in
The
astronomy.
heyday of supernova.
Yeah.
Well, and everything.
And of
I mean,
telescopes.
That's true.
Copernicus
Yeah.
is,
Generally things.
in 1543, and then Tycho also is like he had. Then shortly after that saw a great comet, and that also was like puncturing of all the Aristotelian celestial sphere notions took place at that time.
Didn't
And
see a
then-
gamma ray burst though, did they?
They
No.
didn't.
Losers.
No, they didn't see gamma ray burst, but I don't know. Here's your next stumper. Would
Okay.
you rather see a daytime supernova
Didn't we
or
do
the
this one?
data from a gamma ray burst?
Oh.
So anyway, just saying that was pretty
Supernova.
cool.
Oh,
Although
that
I
was
think
the
that,
stumper. That's not a trivia question.
yeah, I think the healthcare is better now though.
That's
than
true.
In the 16th century
Probably true, yeah.
for most people.
Yeah. We also know to
Um,
like not stare at the sun.
And the TV is better, also for most people.
Yeah, that's true.
Okay, there is, so we sort of expect, based on the population of stars,
Yeah.
that one of these things would be popping off every 100 years or so.
Yeah.
But it's been 400 years, so what's up with that?
Why we're just not looking.
Well, we talked about it, I think you mentioned recently, the problem is all this stuff you like to study
Darn it, dust.
No.
in the way
No,
in
I don't
our
like to say
galaxy.
that dust.
Yeah. So
Anymore.
there's some evidence that there were Milky Way supernova in 1680 and 1870.
Okay.
Cassiopeia A and G 1.9 plus 0.3.
Oh,
There's
Gee.
only 8. They could come up with better names.
Yeah,
I know.
but there's no historical record of those,
Or
probably
hysterical
because of
record.
neither historical nor historical records of those. So anyway, we
But
got to keep
why-
hoping. We got to keep hoping. We'll see
So
them
there's
go.
just like too much dust, so we just aren't able to see them.
We only
They're
see it-
happening, but we can't see them.
That's right. They're probably happening. Okay, I mean, not right now. It's not like every day or week or year, but
Darn
on
it.
the other side of the galaxy, these were both Tycho's and Kepler's supernova were in the sort of few thousand light years from the Earth. So in our general quadrant.
What was
of the
going on in the galaxy during that time?
Just
Well, those
in
were
our
probably
just in
actually
our-
very different times.
Our neighborhood of the
Yeah.
galaxy. Yeah. Next time, I want to talk about how you can fiddle with the light coming out of a black hole and make a cat inside
Okay.
the black hole.
Okay.
Because
Good luck with that.
We can talk about it
Thank
next
you.
time.
Yes, yes. While it may have felt like a visit to the Instability strip, it was just another episode of Walkabout the Galaxy. Walkabout the Galaxy is a labor of love from your astroquarks. Please show us some love by giving us 5 stars on your podcast platform and share with your friends and family. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and soon 2 music videos.
Ooh.
Things are happening.
We have said soon for a while, though.
Yeah,
And also
we're
maybe-
astronomers.
And also maybe
Yeah.
someday our riff tracks.
Maybe
You can
someday our
download
riff
our riff
tracks.
tracks.
Maybe.
Okay.
Yeah. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Thanks to our listeners in Hawaii. We'd love to come visit you.
Aloha.
And around the world, we'd love to visit you too.
It's true.
Stay
We could
safe.
transport there.
I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
Aloha.
Boat.
Boat.